Hello, today I'm going to talk about the embedded energy in contemporary food systems. How does contemporary food chains increase or decrease the energetic inputs and outputs? It's quite a new term that not everybody's heard about, but basically the total amount of energy required to produce a single product is the embedded energy. Today, about 10 times more energy goes into a product than is taken out. And back in 1940, food output actually contained twice the energy consumed in production. Historically, we gained energy from the food system. Now it is a drain, energetically. Additionally, externalities like environmental damage and species loss of contemporary food system also negative. So I'm going to tell you today about contemporary global food system requires mining, transportation, manufacturing, packaging, storage, sales, and food preparation, all which incur a large energy footprint. So there are some significant impacts of embodied energy, especially in producing food. The graph above shows that about 14% of total energy in the United States goes to the food system. And of that, a majority goes to the household, but also in agriculture, in processing, packaging, shipping. Freight is about 3%, according to the USDA. And largely, this is due to the increase of fossil fuel-powered tractors, which replaced a lot of animal labor in the past. Our food system's embodied energy has been selected because it's changed so significantly over the past and is a very large sector of the United States' total energetic budget. So why is this? A lot is due to marketing. New foods in the system, loads of overhead for these new jobs that have been created, and additional packaging and also additional foods that historically have not been in our food system, like Doritos and fruit roll-ups and things like that, that have been totally manufactured by marketing schemes and not historically in our diets that require lots of packaging. So energetically, it's a net negative endeavor, meaning we're putting far more energy into agriculture than actually getting out in calories or kilojoules. This is inefficient and a fail if our goal is to have a balanced food system energetically. So, like I said, inputs include, building farms, tractors, harvesting for fuel, packaging, transportation, storage, and externalities are all energy inputs. Outputs are food and fiber. Now, there have been some great additions of modernity, including economies of scale, which increases production, efficiency, and comparative advantage, which allows for growing foods in climates that are best suited to their growth. Both these actually reduce the amount of energy embedded in the food systems. So it's not all cons, but often net negative endeavor, especially financially, sometimes without government subsidies. Food that never existed previously is rampant throughout the marketplace. So we can minimize packaging, reuse, grow our own, or some things that can be used, like cooking communally reduces energy input. So we're producing plenty, but often empty calories. High amounts of energy needed. Energy used from vital ecosystems, and so there is potentially a change needed. On the consumer end, further down the supply chain, they're changing our diets to more plant-based diets, eating lower on the food chain, discovering new ways to reduce energy also. So, all in all, I've explained the food system embedded energy, and We've discovered that financially, energetically, and nutritionally, our food system produces net negative, which is alarming to say the least. The environment also is feeling some negative effects. This insight brings many topics to the table, which we are all indeed seated at. Thank you, and here's the citation.